Good afternoon, everyone. Welcome to the 6th Annual Idea Challenge at the SciTech Forum. I am Kayla Zweifel. I am with BAE Systems, Inc. in the Space and Mission Systems sector. And I have had the pleasure of serving on the SciTech Guiding Coalition and coordinating the Idea Challenge with my fellow Guiding Coalition members, Brian Kowalczyk and Taylor Fazzini. This is the first Idea Challenge where the young professional participants organized a workshop rather than made presentations. The goals of the Idea Challenge are still the same, though. So we want to give a voice to the new generation of AIAA leaders. We want to enable young professionals to share their thoughts and perspectives concerning important issues in the aerospace industry and to collaborate with their peers across our industry. We also want to create an opportunity for meaningful dialogue between the AIAA community and emerging leaders on critical aerospace issues and solutions. In today's workshop, your participation is key. Our Idea Challenge participants, or facilitators, can you just wave and show people who you are? They will be guiding attendees through problem formulation through our roundtables. We're focusing on technologies and opportunities that are more than 10 years away from being feasible, problems that are DARPA hard. We're not looking for solutions today, but rather the problems themselves. The goal is to have a list of aerospace challenges that will be widely shared with the AIAA community. Throughout this past week, we are grateful to have had senior leadership mentors provide guidance and support our facilitators. I would like to recognize our Idea Challenge mentors now. John Kowalowski, Scott Faust, Steve Frick, Monty Greer, Janet Grondin, Basil Hassan, Kiyoki Jackson, Brian Kowalczyk, Lorette Leahy, John Reed, Nassim Syed, Ricky Shine, and Amanda Simpson. Thank you all for being our mentors. Turning to today's workshop, you can see today's agenda up on the screen. The first step, once we've completed our introductory remarks, will be to choose a topic table. You'll see the tables identified with the different topic areas with their little flags next to those big flip charts. The second step will be to use the paper and pens at your table to jot down any initial ideas and thoughts that come to mind. The second and then we'll get to the ideation process. So today, you'll be thinking about future challenges and opportunities within the framework of the value creation methodology developed by Kirk Carlson. The value creation approach is a simple framework that encourages rapid iteration. By using this methodology, our teams learned how to create compelling value propositions that includes the following elements: a hook, need, approach, benefits and costs, competition, and ending it with a call to action. So you can see on the screen the process that we'll be going through today in your problem ideation, looking at the need, what is really that problem bottom line, what is that DARPA hard problem we'd like our industry to solve? Looking at the approach, why is this an issue? What are the current roadblocks we haven't addressed yet? Looking at benefits, what is really the impact to our world and our industry if we don't address this issue? And then on the flip side, if we do address it, what are the main benefits when this problem is solved? What does our world look like? Who does it benefit, and maybe who might be against solving this issue? And then with competition, looking at if there are any organizations or companies looking at beginning to address this issue. Before we get into the brainstorming time, our facilitators will explain what each of the topics is and what they mean. You can see that some of our topics are derived from DARPA's organizational focus, and some are AIAA's R&D domain lead focus. Let's get started with advanced manufacturing and advanced materials. Where's my person for that?
Good day, distinguished ladies and gentlemen. I am Jessica Blay, a former electromechanical engineer of the Ghana Airport Company Limited in Ghana, located in West Africa. I have an educational background in material science and refractories. Also, I am a current student of the Southern Alberta Institute of Technology and then a future aerospace engineering student of the Penn State College, uniquely one of the best engineering research schools in the US of A. I am here to welcome you all today to the DARPA Idea Challenge Workshop of the 2025 AIAA SciTech. As aerospace enthusiasts, we are keen on shaping the future of aerospace through innovation, ingenuity, scientific and engineering resourcefulness. About 90% of hard technical problems or weaknesses in the aerospace industry could be identified using the NABC method. Thus, the need, approach, benefit over cost, and competition. And massively worked on as we gather here to exchange information and ideologies today. First and foremost, we get to ask ourselves, what are advanced manufacturing and advanced materials? Well, with advanced materials, these are new materials with enhanced properties that are deliberately crafted or designed for superior performance. Example of this is unbalanced carbon fiber laminates or carbon reinforced thermoplastics. This is slightly different from the usual composite carbon fibers. The formation of these new unbalanced materials bonded together develop a flame retardant nature. They are light in weight and they offer a very high strength to weight ratio, which is vital in the aerospace industry. Biofibers are also a typical example of these new materials. They are green technology oriented, reusable with time, and they have a wide range of surface finishes, virtually appealing and environmental friendly. Furthermore, such materials can only be formed using advanced manufacturing processes. Advanced manufacturing process involves the creation method of new materials or refinement of existing materials and the improvement of the manufacturing processes. The 3C design is the main example, and the 3C stands for concern, cause, and a countermeasure. This is distinctive to the usual 3D design process of creating a three-dimensional digital representation of objects using computer-aided design, that's CAD software. This 3C model encourages identifying and tackling the root cause of a problem and the immediate need to implement solutions in addressing, solving them, and improving processes. The 3D printing technology on a 3C material manufacturing, to me, certainly is the forward way to go. Well, here are some introduction questions. Could the incorporation of advanced, dynamic, and multifunctional materials such as affordable cold lasers, unbalanced composite carbon fiber laminate be used in the creation of lighter and efficient aerosystems? Is it possible to come to fruition sooner? The other one is, as aerospace in America improves, is there a compelling need to solve DARPA hard problems and accelerate the certification of new materials and manufacturing processes? This development has grown anticipatory anxiety with time as to what and how new structural materials could be used or alternate with the old for a forward DARPA hard progress. Why the need for this now? Is it feasible to happen sooner rather than later for us now and the next generation? Thank you.
Thank you very much, Jessica. Next, we have autonomy, artificial intelligence, and machine learning.
Thank you. So one of the topics we'll be exploring today will be the use of autonomy, artificial intelligence, and machine learning to shape the future of aerospace systems. As our industry faces growing demands for safer, faster, and more cost-effective solutions, AI and machine learning are emerging as game changers. These advanced technologies offer the ability to proactively address challenges, manage contingencies, and unlock smarter decision-making across aerospace platforms. With that being said, it's important to highlight that we must produce models that are not only technically advanced, but also transparent and reliable, enabling smarter pathways for innovation without compromising safety. So if this sounds interesting to you, I encourage you to join one of the tables here so we can discuss this further. Thank you.
Awesome. Thank you, Jarrett. Now we'll turn to defense sciences.
All right, hello everyone. Today, my name's Nathan Crane. Today, Marco and I will be representing Defense Sciences today, which is one of the DARPA offices. The Defense Science Office, DSO, works to identify and create next generation of scientific discovery to fuel innovation. Typically known as kind of DARPA's DARPA, the DSO develops and manages an aggressive and very forward-leaning portfolio that expands the art of the possible across a broad set of technical areas to create a strategic advantage for the DoD. Like I mentioned, this portfolio is very broad, and it ranges from early idea development and scientific validation to prototype demonstration. To give you a better idea of typical projects within DSO and typical ideas that we can think of today, here are examples of the 6 thrust areas. So first, we have novel materials and structures, sensing and measurement, computation and processing, enabling operations, and examples of that are technologies to support space-based operations or tactically remote environments, collective intelligence like AI and AI-accelerated learning, and emerging threats such as environmental catastrophes or digital societies. So again, this is a very broad topic. We have subtopics of everything at some of these other tables, but if you're interested in a very broad topic that we can associate with defense, then feel free to come to our table. Thank you.
Thank you, Nathan. Next is information innovation.
Good afternoon, everyone, and welcome to this exciting session. I am Dilip Kalagotla from the University of Cincinnati. I'm here to facilitate the information innovation topic. I'm thrilled to see such a dynamic and talented group of professionals gathered here to explore some of the most challenging and forward-thinking ideas in aerospace. Information innovation is all about the transformational capabilities in information and computation. Information is the backbone of modern aerospace. We are especially interested in gathering your thoughts in 4 specific categories. 1, proficient artificial intelligence, an AI that operates competently, behaves ethically and morally, interacts appropriately with humans. 2, advantage in cyber operations such as real-time immersive communication technology, autonomous mission planning and execution. 3, confidence in information domain. This could include misinformation and topics like synthetic reality authentication. And finally, number 4, resilient, adaptable, and secure systems that could be quantum secure or self-healing networks. We hope that these 4 subcategories will guide your thought process during our 30-minute ideation session. Our table will have me and my partner, Aston Cheng. At the Information Innovation Desk, we are excited to get to know more about your ideas to help propel the innovation forward. Thank you for being here.
Thank you, Dilip. Now we'll hear about resilient and assured systems.
Hey everyone, this is Tahir Khan Niazi. I'm a PhD student at Florida State University. And as part of my PhD program, I'm also working at Center for Advanced Power System. I welcome everyone to this Idea Challenge session. And I would like to describe my topic, resiliency and assured system. So when it comes to resilient system, it's the system that can maintain its core functionality and performance when faced with adverse conditions, failures, or attacks. It has the ability to absorb disturbances and still maintains its functionality. It's self-organized and it adapts to changes. It learns from its past experiences and improves over time. And also, it can recover quickly from failure or disruptions. Similarly, when it comes to assured system, an assured system is the one that can provide a guaranteed level of reliability, safety, and security. It demonstrates a verifiable behavior under a defined set of conditions, and also it's kind of predictable performance within specified parameters. Further, it should also be in compliance with critical requirements. And also, it's also based on evidence-based, so it's kind of trustworthy too. I would like to invite to come and join our table and have some kind of a nice discussion and have some nice brainstorming about this interesting DARPA hard problem. Thank you so much.
Thank you, Tahir. As we turn to our next topic, strategic technology, I just want to give a big shout out to Christian. As you can see, he's by himself on this topic. His co-facilitator was not able to attend today, so he's been working on this by himself. So thank you, Christian. You've done a great job so far.
Thank you, Kayla. Appreciate it. So, hello, everyone. My name is Christian Yara from Embry-Riddle University. So, thank you all for being here and willing to participate in the IDEA Challenge. So at this table, we will focus on strategic technology needs and explore specific and overarching technologies to provide trusted and disruptive airspace, sea, and land capabilities. So we will think outside the box about what complicated problems we're facing now for which we have no solution. So suppose we let our mind wander for a bit and visualize the current pace of technology and the trends. How do you see the future? I see more connected systems and constant communication managed by AI, relying on continuous reliable power, vast computing capacity, and hardened security. I see more competition, behaving unexpectedly, and leveraging technologies that confer asymmetrical advantages. I see more congested airspace, more congested orbits, and a push from many nations to establish a permanent presence in orbit and other celestial bodies. I see more complexity in managing an overflow of information. I see a more fragile ecosystem. I see more demands placed on the human body. Now, how do you see the future? What needs we will have? What capabilities should we start developing now? Where are we lagging right now? So, to guide our discussion, consider these areas of interest. Advanced active and passive sensing. So it's novel technologies for detecting, tracking, and monitoring objects. Kinetic and non-kinetic effects, innovation in cyber, electronics, acoustic, photonics, modeling and analysis. 3, command, control, and communications, complexity management, decision-making aids, behavior modeling, and resilient communication networks. 4, critical capabilities for national resilience, strategies and technologies for safeguarding and strengthening our infrastructure. And 5, anything that I have missed. We'll use this time to think expansively and collaboratively. Together, we'll identify innovations that will grow into transformative solutions for tomorrow's challenges. Thank you all, and I look forward to sharing with all of you.
Thank you, Christian. Next, we'll hear about tactical technology.
I need to find a spot where I can attract people to my table. Over here. Hi, everyone. My name is Erin Hong, and I'm a GNC engineering manager at the Aerospace Corporation. Tactical technology provides new options for national security. Wow, spotlight. Options for national security by demonstrating revolutionary platforms and systems with cutting-edge technology. It seeks to develop compelling hardware at scales that demonstrate disruptive capability with designs that reduce risk and cost by managing complexity, and which can be manufactured responsibly and affordably. Focus areas include mission autonomy and rapid evolution from concept to manufacture, as well as designing to support surge production. Examples can include UAVs in swarms and decentralized systems with human supervision, sustainment of satellites for longer lifetimes, either through hardware or software means, air traffic control and collision avoidance of proliferated airspace due to drones at scale. Finally, a current request for information, or RFI, from the Tactical Technology Office is currently seeking to identify sources capable of providing innovative and revolutionary solutions for space-qualified nuclear thermal rocket propulsion, including engine design, development, modeling and simulation, engine integration, autonomous engine and reactor control, engine instrumentation, and engine system integration. It's quite a lot, and so this is kind of the idea of what we'd like to aim for with these 10-year ahead problems. So at my table, along with my partner Isaiah Taylor from Johns Hopkins University APL, we will be reimagining hardware design, development, test, manufacture, and sustainment with a focus on rapid, affordable, and scalable deployment. Thank you.
Thank you, Erin. And last but not least, we will hear about transformative systems engineering.
Hello, everyone. My name is Brooklyn Schnupp, and I go to the University of Georgia. According to DARPA, transformative systems engineering is defined as embracing digital twin components and accelerating adoption of model-based systems engineering and creating frameworks to incorporate new technologies into systems engineering technologies. This expands into adopting and building frameworks to improve the structure, behavior, requirements, and parametrics of current and future problems. We must figure out how to upgrade and adapt MBSEs that are end-to-end capable, yet also fully compatible, alongside creating digital twins that are precise, yet also accurate. If you are interested in transformative systems engineering, please come join our table.
Thank you, Brooklyn. All right, we are almost ready to jump into ideation, but before we do, I want to cover a few ground rules. So we want to make sure that everyone participates and no one dominates. Our facilitators will make sure of this. Be respectful of others' ideas. There are no right or wrong answers here. If anything becomes off topic, definitely use the parking lot. We'll still take those ideas to spread to the AIAA community. With that, let's begin. So if you want to get out of your seats, choose the table that you would like to participate, the topic that you want to do. Make sure to write your name on that name card and begin with we'll spend a few minutes writing down your thoughts. All right, have fun. Practical technology. All right, everyone. Welcome back. How did everyone enjoy your brainstorming problem ideation session? Good? Yay! All right. Cool. Oh. Won't touch anything. So there was quite a buzz in the room when I was walking around and a lot of really good discussion. So I can't wait to hear what every table came up with. We will actually get started with advanced manufacturing and advanced materials. So Jessica, Ben, and Jacob, would you like to join me on the stage? Yeah, you can use that.
Just 1 second. All right, so like Kayla said, our topic was advanced manufacturing and advanced materials. One of the problems that we selected to look at today was for additive manufacturing of high temperature materials. One of the issues is that we want really complex geometries for things like nozzle inlet nozzles and other high temperature materials for space structures or hypersonics. And one of those issues with one of the main forms of additive manufacturing is that it uses high temperature processes to sinter or melt that material. And so for these high temperature materials, we're already starting at a disadvantage to combine those materials into superalloys and other structures in complex geometries. So we came up with a bunch of approaches to how we might tackle or start to look at this problem. And if you guys want to expand on that a little bit.
Yeah. So some of the things we talked about were perhaps combining processes with additive manufacturing. We talked about a little bit about press molding. And seeing if we can take advantage of different processes, take their best parts, take their worst parts, and try to combine them together to create these high temperature materials that would work better in these complex geometries.
So some of the benefits of this kind of DARPA problem is that we want to kind of expand that global access of some of these materials for more access around the world, and expanding some of those harder problems and harder environments for these high temperature materials. So one of the other kind of benefited areas is that maybe we can replace some of the ablative surfaces, so maybe opening up reusable re-entry vehicles for TPS, or thermal protection surfaces for space structures or hypersonic vehicles. And then so one of the things we talked about is kind of competition or detractors to this problem. And so some of the issues was if there are traditional processes or established companies that are already trying to do this at scale or doing these high temperature products at scale, is that there might be some work already in the field to detract from that motivation. And then looking at other low temperature methods to try to combine these alloys. Any other additions?
That's it.
Yeah, we've done the competition. We have to quantify budget.
Yeah, so one of the other aspects to the benefits and costs section of the value-added process is looking at how much budget or implementation issues that we might have with the process. And so since additive manufacturing is starting to be more of an established process for developing products, that budget aspect is not as high of an addition to what the current status is, but that implementing some of these materials might be harder with kind of more rare resources to add to the system. Go ahead.
Well, with the NABC, the last one I'd like to add is the next approach. And here we have manufacturing high temperature materials by using low temperature process or without using high temperature process. And then finally, ensuring ingenuity in creation of refractory materials. And then also controlling porosity. Thank you.
Thank you. Thanks. All right, thanks again, Jacob, Ben, and Jessica. Next, we'll move to autonomy. We'll have Jarrett and Nathan come up first.
Thank you. Yeah, so we looked at AI, something on a lot of folks' minds, and we kind of identified 3 problem areas. The first, which are all interrelated. The first problem was ensuring trust in AI. So how can we trust the, whatever results the AI comes up with? Kind of the second problem was maintaining our human ability to verify the AI. So we talked about maintaining human ingenuity, creativity, problem-solving ability when we're outsourcing a lot of our cognitive and mental work to this AI. And kind of the third problem we identified was related to the trust in the data streams that we're feeding AI, right? Because we don't want to give AI a bunch of data that is bunk. So within the trust of AI problem, our approach, so this is an issue because we need to use AI to replace a lot of these cognitively demanding tasks that can be repetitive. So we want to be able to use AI for labor saving. It saves a lot of time. It increases efficiency. But we want to be able to trust the outcomes. And so we kind of came up with, we needed time, money, capital, and standards as well to develop trust protocols for AI. For maintaining human ingenuity and creativity when AI does a lot of work for us, We need to be able to trust our AI on a human level, but I don't know, we also want to maintain human ingenuity, creativity, and problem solving, as examples in and of themselves. We talked about WALL-E and how, everyone in that movie kind of turns into blobs because the robots do all the work for them. We want to avoid that situation. Someone else talked about how in his, the class he was doing, he had his students calculate the specific impulse of a chemical propulsion system, and someone got like 6,000 seconds or something and just turn that in. Like, we don't want that situation either, right? Because that answer is clearly wrong. We want folks to still be able to think critically. And obviously the benefits are, if we're able to solve that problem, we continue to have human ingenuity and creativity for problem solving. So we can trust our AI and can fully utilize its labor-saving advantages. And for ensuring data streams that we feed into our AI systems are good, this is an issue because of, we identified issues outside of aerospace. So there was a case in Minnesota where they found that they were using an AI for criminal sentencing, and they found clear racial bias in this AI program. That's a situation we want to avoid, especially when our AIs are potentially managing passenger aircraft that have hundreds or thousands of individuals on them. So we think these three issues, trust in AI, maintaining human ingenuity and creativity, and ensuring data streams that we base our AI on are good quality. We think if these three problems can be solved, we think AI we could fully utilize the benefits of AI and machine learning. Thank you. I'm gonna turn it over to Krishna for his group.
Thanks, Nathan.
Yeah, Krishna, go ahead.
Thank you. So I'm in the second team of the AI and autonomy. So 912 flights. These are the number of flights got canceled on a single day at a single airport. Chicago's Keith O'Hare on 22nd December 2022. Over 30 to 40,000 of flights got canceled in the winter span of 2 to 3 months. This number is same in 2023 and 2024. So we were wondering, how can birds fly, especially bald eagle, can land on the tip of a tree branch precisely, whereas our aircrafts having these big runways could not land. So we started with that question, and we thought, can we harness unsteady aerodynamics as the birds can do? And we thought of approaches, like as Eric pointed out, and of course Aditya pointed out too, to combine the model-based approaches with model-free approaches. If neural networks, if one thing they are good at, that is approximating the nonlinear functions. But if you train these neural networks for a long time, it can find solutions anywhere. Sometimes these are not physically feasible. So we want to add model-based approach, that is physics constraints, that is physics-informed learning. So that is the approach which we went on, as Eric and Aditya pointed out. And of course, Matt raised an interesting question that, can we trust this AI? And Eric has a good solution as well. He said that AI need to be a tool at this point, not like a solution for anything. And he said, one quote I liked it, he said that the role of the AI here is to make human beings superhuman beings. And of course, Tammy has a good approach as well. She tried to solve a satellite constellation problem that is, we have so many satellites on the orbit, and sometimes they're going to fail, and we don't know when they're going to fail. She proposed an approach: can we solve this by predicting in the future, when they're going to fail? Something like a minority report, right? And she said that this can also use the approach of a machine learning approach with model-based approach. And coming to the cost, we don't have number on the cost. We thought that the main thing here is that the trainability of such kind of neural networks, and also we probably need to crash some unmanned aircraft systems, I think, because to test those in the turbulent areas. And benefits, as Tommy pointed out, that we can save millions and millions of dollars with such kind of AI systems. And for competition, I don't think there is anybody at this point working, to the best of my knowledge, on the areas of combining these and really happening there in the industry level. So that is what I see in the competition level, so we didn't identify anybody. So that's all about the summary of our table, and thank you everybody for participating, and thank you.
Great. Thank you, Krishna. Wonderful. We will now turn to our defense sciences group. We'll have Marco and Nathan come up.
All right, hello everyone. Think about a future where conflict starts, maybe in a remote place of our world, but we are already there since days, maybe weeks. Or think about a threat, maybe hypersonics, that is coming towards you, but you already know that you will be defeating it. You will be already know how to face it. The word we've been reflecting on this table has been prediction, predictive. Why prediction and predictive? That we can try to introduce it in different sectors, which could be like hypersonics, could be logistics. So we have predictive logistics, predictive left to launch. The reason we identified this need, it's because think about the resource we spend in logistics in moving defense activities, and maybe we are doing it not using the exact amount of, using a lot of resources that could be spared, for example, if we already knew what to do, if you already knew that we were following maybe a wrong way. And how we can do it? We can do it by employing artificial intelligence, by employing predictive models, by employing data collection that comes from all the data that we are collecting, and understanding the way we are collecting this data, because maybe these data are collecting not in the right way, because they are collected, for example, for a human to understand it and not for a machine to understand it. And how is the approach? The approach is, currently we don't have these models. Currently we don't have the data, maybe. We don't have these predictive resources. So we need to understand how to face this problem. Who benefits from this? Well, who is benefiting is definitely the defense organization, the government, our leaders. They will be able not to waste resources, to face time-constrained responses in a more, let's say, free of thought way, and to face dangerous threats in a more efficient way. If we have to see the last point, which is the competition, AI models, artificial intelligence, ML models have been our ongoing analysis by different industries, companies, and different places in the world, and definitely these are potential solutions that has been that are still have to be unleashed for future capabilities. And so we need to investigate, to look deeper in these data analytics to understand if the streamlines of data can change our perspective of defense. That's it. I want to thank our table. We had a very, very deep discussion in different topics. We had also different topics that came up, which deal more with different aspects that we will bring to AIAA. Thank you very much.
Thank you to our defense sciences facilitators. Next, we'll have information innovation.
Thanks, Kayla. Yeah, so like she mentioned, we'll be talking about information innovation. So I think one key theme that we've heard a lot about is trust. That came up in the AI discussion, and so that was a lot of where our conversation was focused. And specifically for information innovation, we were looking at confidence in our information systems. So looking at the needs for that, the problem in information innovation is without confidence, how can we trust the behavior of what our information systems are doing and how that information is being shared? I think it's pretty clear that it's critical to understand what our systems are doing, and for us to be able to cooperate, we need to know like how can we trust the decisions that are being made? So I think the approach that the problem with this issue is like we can have rampant spread of misinformation. I think we're starting to see some of those things happen now. So how can we know that our systems are giving reliable information? And it can be, with all that misinformation, it can be much harder to pick out what's true and what the true information is. And again, another approach and why this is a problem is we need a way to vet that information without stealing the IP. Of course, if things are fully transparent, then it may be easier to understand what those systems are doing, but there's a balance between not having things fully transparent, but then still being able to trust what the systems are providing us. Just looking at the benefits and the costs, having confidence in our information systems will allow accelerated systems and modular development that can speed up development and really not bottleneck where we're currently at. And then looking at some of the competition, I think what we were focused on in the discussion was what industry is doing versus what the government's needs are, and then the competing directions that those are going to. So we can see some competition there. But ultimately, I think we've seen that within the information innovation realm, a big DARPA hard problem in the next 10 years is going to be how can we have confidence in our systems? How can we trust what our tools are giving us, especially with emerging technologies in AI, ML, and those different technologies that are growing? How can we truly have confidence in that and then act upon that appropriately? So, yeah, I think that's what we came up for information innovation, where we'll be solving problems in the next 10 years. So, thank you.
Cool.
Thank you.
Thank you to our information innovation facilitators. Now we will hear from the resilient and assured systems facilitators.
Hi everyone. So I guess it's been like more than 2 decades that we've been promising self-driving cars and drones delivering our packages almost on a daily basis. But I guess it's safe to say that it's a dare to ask you to try your FSD on a snowy night and closing your eyes listening to a music, because it's almost impossible still. And it's even worse in the aerospace domain, where we are talking about drones and SUAS and all these new vehicles that need to be integrated into our airspace. So one of the biggest problems, it's safe to say, is reliability when it comes to autonomous systems. And the problem that we try to address in resilient autonomy is exactly that. How can we make these systems be more reliable? And one of the core issues is that these systems are shifting from a human always being in control to control by exception. And we almost don't have a rough idea of what those exceptions are. And that's one of the core problems that autonomous systems community as a whole, and specifically when it comes to aerospace, where we need more reliability, needs to address and think about. So when it comes to that, we try to talk about the problem that it is no longer a single vehicle issue to think about, but we rather need to think about the whole ecosystem. For example, when it comes to the drones, it's not a single drone trying to integrate into the airspace, but the drone needs to be cooperative with all the other vehicles that are integrated into the airspace, or even uncooperative aircrafts that might be in operation. So thinking beyond one vehicle and also thinking about the control and command, and how does that ecosystem even change? Should each operator be in control of one vehicle, or are we shifting towards MN operations where one operator needs to supervise multiple aircraft, and now the exceptions to think about are even harder, because what if an exception happens in one of those vehicles? What would happen into the ground control station? So all of those what if in scenarios that can happen goes beyond one vehicle to think about assurance of that autonomy. Another thing that we discussed, and one of the core problems that we think needs to be addressed, is that we are talking about learning-based systems. And as far as discussing learning-based systems, the core issue becomes the data. So where are we getting that data? So what we discussed is that traditionally, when we are testing systems, we have some sort of real-world operational data to go off of. But currently, one of the biggest issues and challenges is that we do not have enough real-world data to recreate all these scenarios, and more importantly, come up with edge cases that need to be addressed when we are talking about reliability of a system. So when it comes to the data, we kind of discussed whether we should be thinking about more advanced and sophisticated simulation systems, or should we discuss more about how can we collect more real-world data. One of the problems or debates that came up was that advanced simulation systems, for example, simulation systems that actually can replicate multi-aircraft, multi-vehicle situations or operational scenarios in very high fidelity settings, or like even command and control interfaces, they might be very valuable but the debate is that the real world data always at the end of the day has even more value, but depending on the operational scenario and how can we come up with more novel situations to actually collect those real world operational data is a debate based on the setting and the operational scenario. Another thing that we discussed is that traditionally, especially in aerospace, we've had these like stage-based incremental testing that have been implemented to test the reliability of the aircraft, and that have led to like systems and vehicles that have been more adaptive based on the errors and cases that happen based on each stage of the testing. And we have not been able to replicate that with the newer systems because everyone is implementing their own test plan, their whole like testing scenarios, and it's so different across the vehicles that are now being introduced into the aerospace. So we might be needing to like look into how can we come up with a standardized stage-based incremental tests to test these learning-based systems at each stage of their software as they are collecting data and advancing in what they are doing. And last but not least, definitely one of the biggest problems and issues, especially in the aerospace right now, is working with the regulators and, for example, FAA early on to be able to like tell them what we are doing as into the system, from the system design, development, and also deployment, to be able to like come up with more standardized ways and testing procedures that the regulators also agree upon, so we can kind of maybe come up with ways to certify autonomous systems, because certification process for autonomy currently is one, if not the biggest issue that especially like SUAS and drone companies are facing. As far as the competition goes, I feel like right now, at least in our domain and in like drone OEMs and SUAS, everyone is competing with each other, even government and the industry. So no one is actually coordinating and collaborating together. And one of the problems to address for future, especially for certification and reliability, might be to look into how can companies like think about data sharing, or like collaborating with the government and across like different companies to come up with procedures that are standardized across them and can be really reusable by other companies and players as they come forward. Maybe that will create an aerospace that can actually be cooperative and shared across all. Those are all the things.
Yeah, thank you again for joining in. I would like to add one more point from systems like fault tolerance perspectives. So one of the point we came across in our discussion was how to decide the flexibility or kind of a redundancy in your system from a fault tolerance perspective. So it all goes down to your system's requirements, that what are the minimum system requirements which you have to fulfill in any condition. So based on those requirements, and you can kind of combine it with your failure mode analysis and rate of probability of failure of your devices or system, and combining all these two, like probability of failure of components of system along with your system requirements, they can help you to decide actually how much redundancy or flexibility you should actually add in your system. Also, as she mentioned already, it's very important to have right amount of data and like a real-time data, not only like simulated data, for actually designing a system which is like more fault tolerant and also a real-time. Yeah, thank you so much.
Awesome, great job. Thank you to our resilient and assured systems facilitators. Now we will have Christian come up for strategic technology.
Hi everyone. So in our thank you. In our table, we were discussing strategic technologies. It was a very good discussion. I want to thank everybody in my table, and especially our mentor. When talking about strategy, it's always important to be balanced, right? I mean, we can't put all of our eggs in one basket because we have competing priorities. We got several areas we've got to cover, right? So with that being said, it was very difficult going down to the path of distilling all of the ideas that we have. I had a very good discussion with a mentor yesterday, Steve Frick, and we were discussing how the most difficult part is narrowing down the needs. What goes and what stays, right? So we have several strategic technologies which we saw as important and as relevant. So I'll go with the first one. Hypersonics as a strategic technology, AI in defense, specifically for defensive applications, mitigation and remediation for space debris, communications, and future propulsions. Now, going into the specific challenges and the key limiting factors of those technologies, with hypersonics, we had a very good discussion with materials, right? We need more materials. We need newer materials to be able to do hypersonics right and to take full advantage of the technology. For mitigation and remediation for space debris, one of the most important challenges was policy, right? Orbits are getting crowded, so what are we going to do with the debris? Who's gonna do what with the debris, right? So that's one of the most important things that we have. In communications, we spoke briefly about laser-based communications that increase both the speed and the bandwidth of the communications, and future propulsions. That was a very interesting topic, and we talked about hydrogen propulsion, nuclear propulsion, and some other experimental technologies. So some of the challenges, I already spoke about mitigation and remediation. In the case of future propulsion, one of the challenges that we saw coming up was the incentivization of the right technology with commercial partners, right? And hypersonics, I already mentioned materials, and for mitigation and remediation for space debris, policy. So, in a nutshell, right? Strategic technologies needs are in three basic areas: materials, propulsion, and communications. Thank you.
Awesome. Thank you, Christian. Next, we'll have the tactical technology facilitators come on up.
Good evening, everyone. My name is Isaiah Taylor. This is my co-facilitator, Aaron Hong, and we were the facilitators for the Tactical Technology Group. I am a test and evaluation engineer at the Johns Hopkins University, and my fellow co-facilitator is a GNC engineer with the Aerospace Corporation. So the problem that we chose is the integration of AI into UAS, unmanned aircraft systems, or specifically targeting the or extending the fly-by-wire notion, so replacing many of the mechanical or pneumatic components with AI components. So and this would lead to resilient control of UAS, specifically in a deployed or wartime environment. So, and that's basically the need. So A, which is approach. So for the second variable in the NAVA process, so current loss of signal, usually for drones, they usually do one of two things. They either return to base or they drop out of the sky. All right. If these are sensitive military drones, neither of these are feasible in a wartime situation. All right. So what are some of the benefits if we were to attack this problem? So we would have allied systems that are resistant to loss of signal or to loss of human control or human in the loop. We would have fully autonomous UAS. Right now, there usually is a human somewhere in a loop, especially when you're talking about a wartime environment or where lethal action is possible. Right? What if we could have fully autonomous operation of those UASs? This brings up, of course, a ethical concern, right? Whenever there is a military potential action involved, there has to be a human somewhere in the loop. Well, then one of my colleagues brought up the wonderful idea, well, if it's a non-lethal mission where it's recon or something similar of the sort, we can have fully autonomous drones that are able to do those things by themselves. That will save a lot of man hours from training, operational costs, and the like. And the last one was competition. So who are some of these, or what are some of the, who are the current organizations already addressing this problem? And what are some of the barriers or competitors that may impede a solution to this problem? So shout out to HBCUs. I'm an HBCU graduate myself. Howard University is the first center of excellence funded by the Air Force to study next generation tactical autonomy. So shout out to Howard University. So they are one of the major organizations addressing this problem. Of course, we all know NVIDIA. NVIDIA stock has exploded recently due to their recent innovations in AI. We all know OpenAI as well. They are also a very preeminent organization currently in the moment. Then, of course, we have Anduril. Anduril is doing a lot of UAS development as well as counter-UAS stuff. But we envisioned these three organizations being examples of a partnership that could be formed to address these problems. And finally, what will be our call to action? So we came up with the notion that a consortium of fully U.S.-based companies could be formed that could address this problem for $50 million or less. Not too bad for a government program. So, thank you.
Awesome. Thank you to our tactical technology facilitators. And last but not least, we will hear from our transformative systems engineering facilitators.
Hello, everyone. Again, my name is Brooklyn Schnupp, and I'm a master's student at the University of Georgia. So our topic was transformative systems engineering. The definition of this, again, is embracing digital twin components and accelerating adoption of model-based systems engineering and creating frameworks to incorporate new technologies into systems engineering methodologies.
Hello, my name is Suman. I am from Purdue University. And within our topic, one of the problems that our group identified is how do we determine the unpredictability in digital twin based on users? And some of the issues that are in the way of solving this problem are challenges with finding user-based errors and challenges with user-based behavioral modeling.
Good evening, everyone. I'm Rebecca Kintade from The Ohio State University. Under benefits and costs, we listed out some of the benefits to be. There will be a decrease in the time frame for system test and certification, and we gave an estimate of about 80% reduction in the time if there is high fidelity. And then also another benefit will be that we will be able to predict things that cause failures before designing the system. Some people who might benefit from this challenge being solved will be like the customers, the users. And then a potential cost or who may be against solving this would be, for instance, maybe some of the employees, or if there is like a potential corporate sabotage. So for competition, on our table, we thought, okay, in the autonomous world right now, a company like Tesla, who owns all their systems and gets data from their users, are able to get data to perform such research. So we believe they are currently doing something like this in the autonomous world. However, ways that this new capability will be defeated would be possibly if there's resistance from members of a company who has like a union, or companies that profit from accidents and mistakes. So a shout out to the participants on the TSE table. Thank you so much for a wonderful discussion.
Amazing. Thank you to our transformative systems engineering facilitators, and please join me in thanking again all of our Idea Challenge facilitators. So, as I mentioned, we will be compiling all of today's discussions into a list of challenges that will be widely shared within AIAA, including SciTech attendees and other stakeholders. And as Clay Mowry mentioned at the beginning of this conference, SciTech really influences what happens with AIAA throughout the year, and I envision what happens from here today to really influence a lot of the things that will come up in further future of AIAA. And we really envision this list informing future forum discussions, AIAA technical committees, articles, and more. So be on the lookout for those. If you have any ideas or would like to discuss any of these topics further, I encourage you to stay with your, please don't hesitate to contact AIAA. You'll see Toby's email address up on the screen now. I'd also like to thank all of you for participating in our workshop today and sharing your thoughts and ideas. We encourage you to stay and continue the conversation with our facilitators after the session. And as we close, I'd like to note that we would like to do the Idea Challenge again next year at SciTech. If you are interested in joining as a team member, a mentor, I'd welcome your involvement. Please stay tuned for more information from AIAA. And I want to just say thank you and have a great rest of your day.